And well, I want to introduce myself first. My name is Marta Verde. I'm a Spanish creative technologist and visual artist. I'm currently based in Valencia because I'm teaching here Max and other nerd stuff at Berklee College of Music in the Valencia campus, that is the only campus outside of the States. And well, I'm deeply thankful to Phil and Kane and London Music Hackspace team for giving me this opportunity and trusting me to host this event. And also thanks to all amazing guests who have agreed to come and share their time and knowledge with all of us. And also you can check London Music Hackspace website for more workshops and future events. And I want to say welcome and thank you again for all of you who are present here today as a guest and as an audience. So if you want to write in the chat where you're coming from and your favorite Max field, it would be great. And I think that some of you already typed something. And personally, this is a very special event that demonstrates the diversity in the worldwide Max users community, because when I was thinking about the guest invite, this amazing lineup of a Spanish speaker came up naturally, so I'm really happy about that. They will present their works in Max approach in different fields, and they will introduce themselves, but I want to give a small shout out before. And remember that you can keep your questions and ask the questions to the presenters after the presentations inside of the breakout rooms that will be set after their presentations. And I will start with the order that appears in the in the website. So our first guest is Kevin Kripper. And well, my first contact with visual analog synthesis before deciding to buy physical gear was thanks to Kevin's Vsynth library. And I'm also a big fan of his Instagram filters and all the amazing work he's doing in all the audiovisual field. Then we have Sabina Covarrubias, and I'm really happy to have her here because when I started learning Max, when I was looking for YouTube tutorials or anything online, I always found Sabina's work somewhere. And for me, it's a big inspiration because there is not that big amount of work or presence of non-male creative technologists, and she has been on track for years. So I'm really happy to have her here. And then the third presenter is Francisco Colasanto. And I can only say that I admire your artistic and pedagogic work so much, and I still have here your book that I bought and helped me so much when I started to mess around with Max, and my English was not as good back then, so your addition to the community is really incommensurable, and he's also a Max certificate trainer. So with not further ado, let's go to the presentation. So Kevin, the floor is yours.
Well, thanks Marta for the introduction. Thanks everyone for joining in today. I'm gonna show this work in progress, I guess, this proof of concept of an add-on for doing vector synthesis inside Max. It's an add-on to Vsynth that it's not publicly released yet, but it's gonna be soon. So I'm gonna share my screen now. Hopefully you can see what I am doing. And I'm gonna put this in the next screen. Cool. So, okay. So I have here this patch I was working on before joining the Zoom call. I'm gonna close this at some point and patch from scratch. But what you are seeing here is a mix of Vsynth, which are the gray modules. Those are generating the image. And then the other modules, the one that has the light blue strip, those are the modules that I'm working on right now for doing graphics in the oscilloscope that you can see here. So now I have one webcam pointing to one of my oscilloscopes, and those are the graphics I'm making right now, mixing both video and audio. I have here some more presets I can show. Let's see if I can find the one I want. Yeah. So for example, this one, it's more like a landscape with a full moon and this kind of infinite terrain going on in the grid. So anyway, I don't have a lot of time today to go through everything. So I thought of actually building something with you and show all these different modules that I'm building. So I'm gonna close this and cancel. Let's see. So Wait, you still watching my screen? Okay, cool. No, okay. So this is what I want to do with you. Okay, it's this doodle. So the first thing we can notice here is that it's basically a grid modulated by these spikes. So that's what we are going to do. I'm using a Vectrex, a modified Vectrex. In this video, I don't have it right now in my studio, so I'm going to use my Leader LBO 51MA, which is an XY display. And yeah, so hopefully, just let me know if you cannot see anything or everything cool. Okay, cool. All right. So if you're not familiarized with Vsynth, it's this video synthesizer laboratory for Macs. It's been around for 6 years. There's a bunch of information around, so feel free after to check all that. I'm not gonna spend a lot of time with that. Just to let you know that you can go here to the extras and go to the launcher, and you will have here like a bunch of lessons, patches, and everything to get used to this library. But now I'm going to start directly with the vector synthesis library. So there's a shortcut here with paste from Vsynth vector default. So this opens this. And so now, as you can see, I have one of my Vsynth modules here. This menu will add all the Vsynth stuff, the video stuff. But I also have here another menu, which contains for now all the modules of the vector. All right, so I'm going to turn on the Vsynth render. And as you can see, I'm already visualizing the polarizer waveform generator. I'm using this one because it can switch between stripes, right? And polar shapes. It's pretty handy to try things out quickly. It also has a wave shaper, so I can go from sine wave to square wave to ramp. Anyway, it's very handy for all of this. And as you can see, I'm already having here the grid generator from my vector library. So if I just actually turn on the 3-channel output, and well, in this case, I have here an 8-channel audio device. And to visualize things in this specific oscilloscope, I will need to change my channels here because I'm using channel 1 for the X input, channel 2 for the Y input, and channel 7 for the brightness. And you cannot hear anything because I didn't plug the webcam. So if I grab my webcam module here from Vsynth and connect it to the output, turn it on, you see my face again. Now I change it to the actual webcam and unpin it. And okay, we have here the oscilloscope displaying the grid. And already there is something going on to the brightness. So I'm using here a lot of the MC objects to make this more clear. And also so I don't have to every time plug X, Y, and brightness. So I'm only using one patch core here that carries X, Y, and another one that carries brightness, and another one that carries the sync that we will see it in a little bit. So let me just like correct the settings here and make a little zoom if it allows me. Oh, great, okay. Okay, that's better. Okay, so there are some things here that I will have to mention that you have. You can unplug this, and we will have the full brightness of the grid that's coming from here. And as you can see, in the top, I have 3 inputs. It's X modulation, Y modulation, and brightness modulation. And if I plug this here, this is already getting the brightness modulation from the polarizer because all of these inputs are pre-patched. So that's also very handy. Let me just add a preview here from Vsynth so you can see what I'm doing. Right? So if I open the attenuator of the X modulation, I will start like modulating X and Y with the circle, and also the brightness, it's being modulated by the same signal. But if I make another one here and send this to the brightness, as you can see now, the circle is modulating X and Y, and the stripes are modulating the brightness. So there's a lot of things you can do here. Okay, but let's go back to the example, which is this. So okay, the grid, we already have the grid, right? There's another thing though that it's happening, that instead of the brightness being modulated by the circle in this case, well, it's actually modulated by a circle, but it's another waveform, right? To make the radial mask, because if we see the grid again without the brightness and without the modulations, it's a square, right? It's a square. So what we have to do now is to make a circle out of this. So in this case, it's pretty easy. Just for clarity, I'm gonna change the patch cord to the brightness modulation input. And so basically to make the radial mask, I'm gonna just stop the speed, change the frequency back to 60, and then make a square wave, right? So now I have a perfect sharp circle there. And maybe I'm gonna adjust the bias here and the phase of the oscillator so I can have a better circle. So yeah, so we have the circle, yeah, there with the grid. Also in the generator, we can change the amount of the refresh rate, right? So this is actually the grid being drawn at 1 Hertz. And if I start increasing that, at some point, I'm gonna trick your eyes, and with the persistence of vision, we will have the actual grid. We can also change the amount of lines or divisions, all of that stuff. We can also have here a drift of horizontal and vertical drift. So anyway, it's pretty, if you're familiar with Vsynth, it's pretty much the same logic. It's a little bit more complex because it's mixing both audio and video. Actually, I didn't say this, but if you wanna like see a better explanation of how these new modules work, there's a video on my YouTube channel. It's a half-hour video of me showing a lot of things of this. And there's also a 45-minute video of a presentation I did last month in Vector Hack Festival that you can check out, that actually go into the different modules and options like more in detail. So, okay, back to this. Let's just put 25 lines here for the grid. And let's check what's going on here. Okay, so let's focus on the spikes. The spikes are a little bit more complex. It's a little trick I do actually with Vsynth. So to do that, I'm not using X and Y distortion here as I showed before, because X and Y distortion actually distorts the graphics to right and left and up and bottom. And what I want is to displace everything from the center towards us, right? So for that, what I'm doing is actually amplitude modulation, but there is a handy module here called displacement, which again, if you're familiarized with Vsynth, it's pretty much the same as the displacement 2 module in video. Still, again, this is a work in progress, so the interface might look a little funky right now, but at some point it will look similar to Vsynth. Okay, so here's the displacement. The displacement allows me to move everything and rotate, scale, and also modulate those parameters. So for example, let's see. So at this point, the modulation inputs works only with audio, except the generators that also accepts video. So for example, if I add here just a sine wave at 61 Hertz, let's say, and send this to the, let's say to X, Y, and scale. Let's send that to everything. So as you can see now, I'm displacing both with the sine wave, right? But I don't want to use the sine wave. In this case, I actually want to use video to make these displacements. So for now, there's a module called texture to audio. So this will allow us to transform any video or texture we create in Vsynth to audio to use as modulator of the other modules that are not generators. So if I grab the sync from the grid generator and send it to the sync input of the texture audio, and if I send whatever video to the texture input, now I can use this as my modulator source for all the stuff right now, right? So now I'm using the sine wave coming from the polarizer, this stripe, to modulate the scale of the grid, right? Okay, so the spikes. Let's see if I remember actually how to do the spikes. So what I would do for doing that, it's basically, so as you can see, we have like little points, right, that are doing these displacements. So I would do that with a pixelator actually. So there is this handy module here from Vsynth that it's the pixelator. So let's just grab it. And let's keep this open so we can see what our modulation looks like. And since I'm not pixelating that much, we can still have like the sine wave. But if I put like 5 here, as you can see now, there's like blocks, right, that are displacing this. It looks like, yeah, like steps. So that's a good sign. Let's increase this. Maybe let's grab the initial point of the scale to 0.5, so we make it smaller, and then the displacement can be more intense. So yeah, so my trick here, it's basically make a morph between the stripes and the radial shapes that the polarizer allows me. So I just basically move the crossfade here a little bit. Just for clarity, I'm gonna also add one preview before the pixelator. And then just maybe move the angle a little bit of the stripes, then decrease the speed. Let's just make 25. Increase the frequency. So now we have all this distortion going on. And then we can also decrease the bias, which is a number that it's add to the original image. So basically increase the brightness of everything, but like it also increase the brightness or decrease the brightness of the blacks and whites. So like if I increase the bias, you will see that the blacks now are turning white also, right? But let's do the other way around. Let's do this less white, so we have more black sections, and we have like these little spots here and there. I'm also going to decrease the brightness of the oscilloscope because it's pretty burned. Okay, you can see this better right now. It's close enough to what I'm actually seeing in the scope here. So there's one more step to do here to get the spikes, which is interpolate the pixelation. So now you can see all these squares, but if I hit this button, I make like this diamond shape instead of having the solid squares. And now you have these little spots here and there. Let's actually increase a little bit more the speed. Oops, 75. Okay. And okay, this is looking okay. Let's just double check our original video. All right, so what I'm seeing here also is that I'm moving I'm like drifting the lines of the grid. So I'm gonna do that. And also, I think I'm rotating also the whole shape. Maybe with a sine wave or something like really, really slow. So let's do that. So maybe put 20 lines. And this is another thing I didn't mention, that also the spikes will change depending on the waveform I'm using. So as you can see now, it's like more dramatic, the appearance of the spikes. That's because I'm using a square wave. But if you smooth that a little bit, changing the wave shaper here, you will have like this more smooth movement, which you can also actually get, and we can do that. You can also smooth the square wave using the temporal filter here from Vsynth, which basically is a frame interpolator. So smooth the frames, basically making everything more slow. So I can put that here. And increase a little bit the smoothness. Yeah, okay, that's better. So I'm just gonna move a little bit, like drift a little bit the lines that are making the grid by changing here this horizontal speed and the vertical speed, right? And I also said that I was rotating the whole shape. So I'm just gonna add a really slow sine wave. Let's say, I don't know, 0. Well, let's try 1 Hz and let's decrease from that. So I connect the waveform, the audio waveform, to the rotation modulation input. And let's just put here, I don't know, 3.1416. Okay, that's very fast. So yeah, let's put just like 0.05. Still very fast. Yeah, something like that. It's very, very, very slow. And I guess what I'm lacking now is this distortion in the middle, right? It's like a bubble thing going on here. And for that, there is another handy module from the new library that it's called fisheye, which someone could argue that the algorithm is not actually a fisheye, it's another thing, but it looks like a fisheye. So let's just call it fisheye for now. And I can add this, let's do it before the displacement, but I mean, I can add it afterwards also, so it's not like a big deal here. Yeah, so that's the ball. Maybe if I decrease this a little bit more and increase the modulation. I exaggerate a lot here. And yeah, I think it's pretty close to what I was doing here. So that's the original. This is the new one. So yeah, if I'm not checking out the chat, so if anyone has any questions, I'm not like seeing it. Okay, there's no questions. Cool. There's any questions before I finish? I think I'm right on time, right? Like, okay, cool. So yeah, that's what I want to show you. Something more. There's a bunch of modules here, guys, I didn't show. So if you want to know more about the new modules, please check both my video on my YouTube channel and on Vector Hack Festival YouTube channel. And yeah, this is gonna be released, I guess, soon. I don't want to say any date, but at some point this year or early next year. I guess with a better interface and with a few more modules I'm developing right now. But there are crossfades. You can make several shapes and crossfade between them, have them both at the same time in the screen. also sequence them. There's another output I'm making, so you can actually use more than one scope. That's something I like. I can show you here. I have like several, so I can send one of the things I'm making in one of the scopes to the other ones and start like switching and making like a dialogue between them. So yeah, I think there's a lot of potential here, mixing these all new audio-based modules, taking advantage of the MCs to make the patch really clean, because if not, you will have like every time to connect 3 patch cords, which is a lot. And also using all the Vsynth potential that it's already here to make all kind of shapes and distortions to these audio-based generators and processors. So yeah, thanks for watching and listening.
Thank you. This is really black sorcery for me. It's really fun to see. Now I want to just buy one of those screens, an oscilloscope, to start working on. I will lose all my money. Thank you, Kevin. Thank you so much. And I think that now is Sabina's time. I don't know if Sabina is ready to share her screen.
Yeah, sure. Well, hello, everybody, and thank you, Kevin, for this great presentation. I can't wait to use your new synthesizer. It's awesome. So I will share my screen here. So I want to give you guys like a big picture of what I am doing with Max. So let me choose the right screen. Okay, so a big picture about what I am creating with Max, and then talk about some specific projects. So I've been using Max for probably more than 20 years. And right now, the projects that I am building with Max is visual music, interactive art, audiovisual installations, live visuals, fixed images, and also mixed music, or it's a kind of electroacoustic music, which is also in French is called musique mixte. And I also teach composition and live visuals in Paris VIII University. So I would like to share some examples about what I've done in mixed music. Mixed music, for those that don't know what is that, is music where a musician is playing live and the computer is processing the sound of the instrument in real time. So I'd worked with oral tradition musicians, and so using Max in order to build a multimedia score, which includes audio files. So in this case, this specific project is a project that I made with a musician from Senegal who is playing this drum called the talking drum. And so the Max patch was useful in order to allow the musician to listen a key. So he was following that audio key. It's like a audio score. And with this audio guide, he was playing the music. So we'll show you a little about the results. So as you can see, well, Max is also processing the sound of the instrument with resonators, etc. And so this is something that is called a multimedia score, because he doesn't read music, but he can understand an audio guide which contains some keys about his traditional music. So about fixed images, I worked also, I like creating fixed images. So all this is available on my website, which is my name, and well, I later will give you the link. So these images are made not only using jitter, but also like a bunch of things. But in jitter, I was using this subject called JIT-DAT BGB in order to generate noise, and then this noise allowed me to make pixel displacements in photography. And so the result is quite surprising. And here, for example, the original picture was, I think it was the city of Copenhagen, gardens, etc. So this can't be done in real time in an acceptable frames per second, because the detail is really, really detailed. This is a really large resolution, because all these are pictures taken with a full frame processor camera. And then the pixel displacement, it goes really, really slow in order to achieve one of those. So I wish one day processor and GPUs will be so fast that I can do that, like in a video acceptable speed. So this is something I call algorithmic photography. And let's see what else. So about live visuals. So I also like doing just the visuals, and so other musicians are playing live, and the way I like to do live visuals is some things are already pre-programmed. They are audio reactive or also audio generative, but I also like playing, like you can see here, like with the musicians, like if another musician playing with the visuals. So I am connected with the musicians, following the energy of the music. And so this particular project was called Límite Roto, presented in Keroxen Residency 2020. It was conceived by Jara Alonso, who is also a great mixer, and he's living in Sweden. And so I think that live visuals, when they come really, really alive, is because I can play with the musicians also. So building an interface which allows me also to play and to touch the instrument, like turning knobs and sliders. This contact is very, very important for me when I am performing. And so visual music, well, I like creating works or audiovisual pieces. This is the case of Viaje, this piece, who is 45 minutes long, and it's conceived to be played live with a modular synthesizer, and in this case, Max is used to generate the visuals from the sound of the synthesizers. And if you guys are interested in seeing that, you can go to my webpage, and there is an article here. It was published in the Ableton blog, and there is a great interview made by I forgot the name of the author, but I am talking about this because here I am talking a lot about the technical stuff, about how the piece is made, and also how the patch was programmed, like talking about how to use the GPU and the CPU inside a patch, how to achieve an optimized patch in order to do a live presentation involving sounds. So talking about the specifications of the GPU that I am using. So if you're interested about the technical stuff, you can go to this article. It's also in my webpage. And so here is also the diagram of the setup that I use for this piece, which is, well, the physical instruments, the hardware instruments are a vocoder, a modular synth. So the vocoder goes into the modular. So there I am creating delays, and also I think that also, yeah, resonator. Then it goes to the audio interface. And so Max, in this case, I was using Ableton Live in order to create a visuals inside of Max for Live. And also why Max for Live in this case? Because I also wanted to use the sequencer of Ableton Live, who was useful in this case to give sometimes clock to the synth, and also in order to launch some clips, audio clips. And then the projector is connected to the computer. So the visuals, they are coming from Ableton Live. And so, yeah, so more so this information is in my website, so you can go there and you will find, I mean, if you navigate here, you will find all the information that I am providing. So this is kind of the same diagram that I showed you before. So I'm not going to repeat this. And so I wanted to show you the architecture of a patch, the architecture that I like using for a patch who is conceived for playing audiovisual works live. So I have video inputs and audio inputs. So these video inputs they go to a video analyzer. So this process is held by sometimes by the GPU, sometimes by the CPU, and then I get different generators. So from the analysis, also the audio sources, I can analyze this audio, like for example, getting the average amplitude or the fundamental frequency or FFT data, for example. So I am using the results of this analysis. In the case of video, it can be the amount of color or amount of movement for specific pixels, etc. So the results of the analysis are allowing me to have generators. So these generators are used to synthesize images or to synthesize audio. Also, I can also use this analysis, the results of this analysis, to drive effects like audio effects or video effects. And so this is the part where the visuals are generated, or the audio part is generated. And then there is the part of video diffusion or audio diffusion. So here is where the audio spatialization can happen. And after the video diffusion, well, here is where video mapping could happen. And here I have a part, a module who is going to be the master levels meters. For the master levels for video, at the end of the chain, I like having the brightness. It's very important because some theaters might be darker than others. So brightness at the end of the video chain for live presentations is key. And then, well, I put here render. This is like the last part of the process of the visuals. And finally, the video outputs or the audio outputs. And so for audio spatialization in real time, I can use the SPATs of the IRCAM, for example. But recently, I am in love with this library. It's like the second version of the HOE library. This was the high order ambisonics library. And right now, in the laboratory where I work, which is the CICM, we are developing this ABC lib, which I will show you some examples. So this is a specialization library, which is using the high order ambisonics technologies. So you can download it from here. So if you can just browse for HOI library, then you click here for searching the IBC live. And then once you load it and you install it, here in extras, you will find amazing examples really clear about how to use the library. So let me bring this to my main monitor. Just a second. I want me to do this. Here we go. So this is the first help file of this library. And so in this case, well, you can, it works having encoders. So the encoders is responsible to encode the audio signals to emulate a specialization. So in this case, you can see that this library also contains synthesizers. Then there is a part, well, here there is a process where you have this sound source. Then you have, this is the encoder. So this is, we are in 3-order ambisonics. So we have, these are the harmonics of the ambisonics. And then here you have the decoder. So we are decoding this for a octophonic work. And so you can explore this library. So the great advantage about working with this technology, which is high order ambisonics, is that you can adapt your work for octophony or quadraphony or stereo, and you don't have to make the patch many times, because the encoder and decoder part will handle to adjust your work to the correct specialization. And it's very handy to adapt for different holes. Like if you have a setup with 12 speakers or 8 speakers, so that can be handled really easy. So this is a whole topic that is not easy to explain here in few time, but I just will leave this here and you can explore the help files of the library. So, and just for concluding, I would like to talk to you about a topic that probably, well, it's not technical, but it's like what is behind the scenes in my experience as an artist programmer. So I would like to talk about digital wellness for artists, because it's something that has been key in my process of creation and programming. So how to be able to produce quality projects in a limited time for specific contexts and budget. So at some points, I had lots and lots of work, but to accomplish optimized patches like in 2 days or crazy stuff. So the notion of wellness started to be important for me. So we need great resilience, and what means in order to create resilience for a programmer or an artist, you need digital health. And this is something that I am addressing also with my students to create good habits, because now we're more and more in front of the screens, and so we need to address this topic. I mean, for me, it was necessary. So what do I do when I program? I just create awareness of the body state, listening to sensations and thoughts. Like when we practice piano, we need a position of the body. Well, the same is for me for programming. When my position is correct, I can think more clear. So, and limiting the work of screen to the minimum possible. The less hours on screen, my work is more, I can perform better and more. And so how to limit the hours in front of the screen? Like I plan my patch before going to the screen, and with diagrams and with clear objectives, and also create discipline for getting order, like organization in the patch by modules, so I can reuse models that I used before. So over and over without building from scratch all the time. So very precise objectives before going to the screen, being sure what I want to obtain like every time. So that allows me to reduce the time I'm just lost and hypnotized by a very brilliant screen that sometimes that gets me lost. And so the translation of these objectives into specific tasks has been key also to work very fast. And so when I am patching, I have a list of like a to-do list, and so I'm just checking that list. Why do I am so strict in my programming methods? Because I differentiate the work which is programming and also the work which is creative and expression. So I discovered over this, more than a decade, that I can be more expressive and more free in my work as an artist when my patch is my instrument and I forget it is there, and this is because the patch is really well optimized, and it won't. Well, it can sometimes crash. Well, unfortunately, never in performance. But in order to achieve an instrument, I talk of a patch like an instrument that I forget that it is there, and I just can be creative and expressive when I am on stage. Is because I differentiate when I am building the patch, when I'm in front of the computer, if this is a programming stage or if it is the creative or expressive work. So, and also in every patch that I do for a project, I like to put the priority is expression and is, well, let's say art. So everything, the programming and technique is going to serve that expressive objective, and this is key in my programming way of in my way to do things with Max. So I think this is all what I want to share with you now, because we have few time. But if you have questions or something that you want to comment with me, I am open to respond, and thank you for listening.
Thank you so much, Sabina. I will print those keys and those ideas for my students as well. I think that the digital wellness is really crucial during those days. Really special. Thank you for sharing. And well, now I think it's time for the last presenter, that is Francisco Colasanto. So if you're ready, the floor is yours.
Can you listen to me? Yeah, it's okay?
Yes.
Okay. Hola a todos. Hi, everyone. First of all, I want to thank Marta very especially because she kindly invited me to be here. So I'm very glad for that. And yeah, and yeah, congratulate Sabina and Kevin. I know they work. We were in contact several times, and yeah, for me they are amazing artists and programmers. So thank you very much. I will use two computers because this is my iPad, and here I have a computer. So I will share my screen in the computer. Okay. So first of all, let me tell you something about me. I'm as Marta said, I'm a certified trainer in Max MSP. I started to work with Max probably in 1998 or something like that. So yeah, I'm quite old. I don't look old. I look very young, but I'm old. And yes, and when I started to work with Max, for me was a big discovery because in those days I was working a lot with a software called Sound. Well, you know that software. And for me, Max was like you know, my first impression was Sound with boxes, you know, something like that. So for me, it was much. I mean, it was a surprise. And I started to work with Max every day since 1988. So yeah, and yeah, here I have my project. It's called Dr. Sopa. This is my project, my artistic project, and here you can find some things, some material of my work. I work mostly with synthesizers too, with analog synthesizers, but a lot with now I'm working a lot with MC objects and creating patches to composing from there, because I think that there is a huge, it's a very good tool to create multi-channel things, and not only multi-channel in the sense that send the sound to an octophonic system, but to create a lot of layers of things that you can change it a little bit and to have very, very interesting textures that you probably cannot have it with any other software. So I'm working a lot with that software, with that part. Here in Spotify, you can find my work, Dr. Sopa. And I am the deputy director of the Mexican Center of Music and Sonic Arts here in Mexico. We are in these places in a small town called Morelia. It's like 3 hours from Mexico City, and but here, you know, it's probably, I don't know. Yes, it's not a big place, but at least we don't have many things to do, but to work with Max, and so yeah. But yeah, the center, CEMAS, we have a lot of concerts and things and activities. In fact, Sabina came here a couple of times. Kevin is going to come, I hope. So and at CEMAS we have these courses too. These tutorials. In fact, Sabina has one here. Here's Sabina's course, but we have different ones. A lot of and all of them are subtitled in English. So yeah, and there is a lot of different topics and very interesting things. And okay, so let me show you what I want to present you today. This is something, a tool, a tool called AMI, for algorithmic music interface. And I wanted to create a tool because, I mean, there is a lot of softwares to do algorithmic composition, stuff like that. But my I feel that some of them are too difficult to use for the regular people, you know, for the people that doesn't want to know about mathematics or things like that. So I wanted to create a system or a tool that is mounted, I mean, that works in a very popular system, in a very popular environment like Live, Amazon Live, and that is, because Live works with Mac and PC, that is very good, and because it has a lot of development and a lot of documentation, to me was my first choice to create this tool. So yeah, this is here. I have this, and here you can open this editor here, and you can generate pitch and rhythms and dynamics. And so, for example, here you can choose the algorithm you want to use to generate. In fact, you are going to generate with these algorithms, you are going to generate these profiles, different profiles, and you can map those profiles using different nodes, no? So, for example, here I have, let's say, I don't know, L systems, and now here you can choose between two different L systems, no? And with some variations, no? For example, this one is another one. Here you can specify the rules of the L system, no? And you can immediately you can see here that you can create this kind of auto-similar things, no? Sorry, auto-similar shapes, no? Or profiles, no? So, okay, so I have this, and I have, for example, chaotic systems and maps 1D. So, I mean, these are not new things. I mean, there is, in fact, there were old objects called a chaos and in Max and SP, but I created all of these using gen objects and in a way that is easy to use. For example, you use this congruential algorithm. You can modify here, no, the parameters of this, or if you use logistics, I don't know, no, something like that. And here you can see an histogram, no? So for example, I can choose out for aleatoric random walk, and okay, I can generate this. And now I can choose the notes. I can use scales, a lot of different scales. I can choose the notes directly from the keyboard, or I can use, I can write down directly, you know, a pitch class set. For example, 5, 6, I don't know, just like that. And I don't know why this even works. Let me check. Okay, I need to check that because I'm using two computer because my good computer died a couple of days ago, so I need to move everything to an older computer. So hopefully this is going to work. Everything is going to work. So. And yeah, so for example, I can choose this, and I have this profile map with these nodes, and I can have this octave. I can choose the octaves. So now, yeah, you can listen to that. Okay, perfect. So I have this, no? Okay. Okay, I will choose another scale. Okay, that's different. Okay, and now here I can say how many notes I want to generate. Now here I have the rhythms. With the rhythms, it's important to say that I wanted to create rhythms that you can read to, know that you can create a score that you can send to a musician, to a performer. Because I mean, with a computer you can create any rhythm, any crazy thing, but I need to create something that is, you know, visually the score is, you can interpret that. So I created a system that divides the quarter note or the pulse in different parts. So for example, here I can divide that in in 16 notes, in triplets, etc. And now I can generate something, I can put some silence, okay. And then I have this rhythm. And here I doing the same thing with the dynamics, but here with dynamics, I can choose, for example, this kind of things for the graphics, graphic generator. So for example, I can say, okay, I want 3, 4, and 2. So I will have 3 notes with this dynamic, 4 with this one, and 2 with this one, something like that. So I can create, let's say, a rhythm with the dynamics, no? So okay, I have all of this. I push these buttons, and now I have everything right down here in this chord here. Now I can listen to that. Okay. So now I can write down. I can write down this result in this in a track, in any track, in any MIDI track. If I put another track here, I can put it here too if you want. So and let's say I choose this first track and I said the first note. So right, and now I have it here as a MIDI track. So now with this procedure, I mean, with this system, it's very easy if you want to use now this in another context, not only in Ableton Live, but you can export this as MIDI, and you can use it in any software you want, or you can export it directly from here in Music XML, so you can use it in the finale, for example, if you want. And okay, but this is one part. So here, let's say that I generate different things. That I will do very fast things. For example, I know I have this. Let's say a rhythm, okay, and I will write this in the second one, and I will do another one with another scale and another in a chaotic system. Let's say something like this. Okay, something. Okay. Okay, and one more. Okay, system. Okay. Okay, something like this. So now I have here 4 different, let's say, melodies. I mean, the word is not correct. It's not sequences, let's say. No. So I have 4 sequences here now. And now the thing is that, to me at least, I worked a lot with softwares called, you know, the Open Music or those kinds of softwares. And to me, I realized that sometimes it's very easy to generate things, a lot of things, because you push a button and you start to generate with different parameters. But sometimes it's very difficult to relate those things, no? Because if you, I mean, here in this example, I'm only using 4 sequences, but let's say that I have 100 or 100 sequences. So how can I relate those sequences? How can I say, okay, but which ones are more related in some ways than others, no? So the thing I did, it was all the sequences that I'm storing here, they go to different kind of analysis algorithms, no, processing, and all this analysis is going to go to a database. So, for example, here are the analysis I'm using. No, for example, standard deviation of the pitch, entropy of the pitch, some common of the pitch, I don't know, something else, edit distance, entropy of the rhythm, chronotonic distance, mean dynamics, etc. A lot of different kind of analysis techniques, and all of this analysis is stored in one place. So here I can say, okay, let's see that, for example, if I do, let's say, entropy of the pitch and chronotonic distance, and I say, okay, I want to analyze this track, and I want to select 4 of them. Okay, so if I do click here, for example, you see, now it says 1, 2, 3, 4. So that means that taking, I mean, from this sequence, this one is the most similar to this one, you see? And after that, this one, and after that, this one. But when I say similar, I'm not saying that the sequencers are equal, because they are similar for taking into account the entropy of the pitch, for example. No? So you can have 2 sequences that are very similar in the amount of entropy, but they sound totally different. You know, I mean, you can choose different kinds of analysis systems to have some inputs that you can use to relate the sequences. You know, so for example, if I'm using now not entropy, but let's say edit distance, and I say, okay, the same thing. I don't know, this one now 1, 2, 3, 4, no, and this is totally different, no, you see. So, and you can use this all across all the tracks. So if you have sequences here and here, and a lot of tracks, the system analyzes all the tracks. So you can relate. You can say that this sequence is most similar to this one, and to this one, and to this one, etc. No, that's the idea of the tool. And for me, it was very important to create something that now you can see here. I have all these other tracks, and to me, it was very important to create this program. I can open the patch, but I don't know how much time it's going to take. Let's check. But to me, it was very important to create a system that is easy to me or to anyone that wants to do that, to add more algorithms to the generation or more analysis techniques, you know. So for me, this is only the beginning of the work. And for example, I want to add constraints, algorithms to create to generate things. I want to use more. I want to have a better rhythm section. I want to use. This is not generating not polyphonic things. So I want to generate polyphonic things, so etc. No, so this is only the first step. No. Yeah, somebody's talking about Bach objects. Yes, I'm using a lot of Bach objects here. And because of that, I will give you a link to download this tool if you want. But you have to install the Bach tools, no, they need Bach tool to work properly. So you need to install Bach and Cage and Dada object. Dada, I use it Dada too. So yeah, you need to install that. And let me show you. Be patient a little bit. Yeah, well, wasn't that bad. So, okay, let's see. Yes, I told you this new machine is quite old, so it's not very fast. And I don't know what's happening here, why it's not opening. Yeah. So here you have, for example, this part, every one of these ones, these small modules are the analyzed systems, no? So here you have entropy, I don't know, mean, with distance, etc. No, so you only need to add one more of these and to send it to the database, and that's all. No? So it's not that difficult to add more analysis system. And the same thing is if you go to the editor and you come here, for example, to the generators here. Yeah, all the generators are created with using gen objects, not audio gen, no, data gen. And here, well, for example, this one, I have this logistic chaos system that is, I mean, it's very, you can see that it's very easy to implement here. Some of them are a little bit more complicated. No, this one are very easy. I don't know. But yes, I mean, this possibility of using this kind of recursive algorithms in Gen is very good because you can create all this stuff. So yeah, I mean, probably it's not that easy to modify the patch, but you can do it if you want. It's not that difficult, no? And let me show you, for example, here I have an example. Here, for example, no, this is another thing. Here I have an example of a small music I created as an example. It's not a masterpiece, but I created these sequences using this patch, and I analyzed these, and I created I created this sequence of sequences and exported that to Finale. And in Finale I used let's say this like a Pierrot ensemble to create music, and I add some frullatos or tremolos, something like that. No, so for example, ejemplo final. No, this one is this one. Okay. So let me see if you want to listen to this. I can put this here probably. Okay. Let me know if you listen to that. Sorry, but I need to. Okay. Again. Okay, that's all. No? So it's a small example using this, and here well, I have the Finale score of this, but I don't want to open Finale 2 here. So yeah, and if you want to try this here, this is the web page. I will put this in the chat. Okay, and from here you can download this. You can download the tool, but as I say here, you need to install Bach, Cage, and data. Here's the address, the link, and so that's all. And yeah, and you can try my tool, and if you have any problems, probably you are going to have some bugs. I don't know. But if you have some bugs or something, you can tell me, and yeah, because this is a work in progress. I need to I need to add a lot of more things. So yeah, but that's all. So that's the thing that I was working now. Now, I mean, I'm working more. Let me show you only the last thing, because I told you that I'm working a lot with MC objects. And now, for example, I'm working with this kind of thing. No, for example, here I have this patch I created with MC objects, and this is the kind of score, let's say. And I'm using very simple things like sinusoids, or mostly sinusoids in this case. And but I'm using a lot of different delays, MC delays. No, each delay with different times and different envelopes and different. I don't know. I can use different filters, different feedbacks, etc. So I create these kind of things. Let me see if this, for example, this. Yeah, so I can change, for example, this. Okay, so I can, and I'm using this to create a lot of textures, and then I export these textures to Live or other software, and I'm creating music, thinking from MC objects in Max, because I think that there is, to me at least, I think that there is a big opportunity of creating music without the constraints, without the, you know, the environment, like a DAW, no, like Live or Logical. That, because with those environments, sometimes you tend to think in a specific way. So with this object, with these max patches, you can create things from other places, no? As thinking, starting from other places, and I think that is quite cool. So I'm researching on that now. So that's all. Sorry for my ugly English. And yeah, if you have any question later, thanks.
Great. Fantastic job, Francisco. It was really, really cool.